This lesson will introduce the normal distribution and look at some of the calculations that can be performed when we know that a probability distribution is normally distributed. Here we have a frequency histogram with a couple of characteristics that are notable. Firstly, the histogram is symmetrical, which means that the mean is approximately equal to the median. And secondly, the number of values decreases as we move away from the mean. If we're making many measurements, the distribution can be modelled using the bell-shaped curve of a normal distribution. A normal distribution will follow this 68, 95, 99.7 rule. These numbers signify the percentage of area under the bell curve within 1 standard deviation of the mean, within 2 standard deviations, and within 3 standard deviations. We have a cereal box which is printed with 500 grams, but in actual fact the weight of breakfast cereal in the boxes is normally distributed with a mean of 512 grams and a standard deviation of 8 grams. We want to know the probability that a box chosen at random contains between 504 and 520 grams. I'll draw a quick sketch of a bell curve. The mean is 512 grams. 8 grams is 1 standard deviation. 512 plus 8 is 520. And 512 minus 8 is 504. So this question is really asking us what's the probability that a randomly chosen box contains a weight of cereal lying within 1 standard deviation of the mean. 68.3% of the area under the bell curve lies within 1 standard deviation of the mean. 68.3% of randomly chosen cereal boxes will contain a mass of cereal between 504 and 520 grams. Next, I'm going to consider the probability that a randomly chosen box contains less than the advertised 500 grams. 500 grams is 1.5 standard deviations below the mean. We're going to look at a standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. And we can calculate the z-score, or the standardized score, by subtracting the mean and dividing by the standard deviation of the scores. In our cereal box example, the standardized score for 500 grams, negative 1.5. In other words, the z-score, or the standardized score, tells us how many standard deviations our score is above or below the mean. The probability that our x value is less than 500 is the same as finding the probability that a z-score is less than negative 1.5. And in the days before sophisticated calculators such as we have now, z-scores were provided in a table like this. We read down the column negative 1.5, and the second decimal place is where we read across the rows. So this is negative 1.50, negative 1.51, negative 1.52. This is the value we're looking for. The probability that our z-score is less than negative 1.50 is 0.0668. And that's the answer to our question. That's this area here, 0.0668. Now we can answer the final question here. In a random sample of 100 boxes, how many would you expect to be underweight? Well, we can take that probability and multiply by 100, but of course we can only deal with whole numbers of boxes of cereal, so we'll round to the nearest whole number, and we would expect approximately 7 out of 100 boxes to be underweight. Now, just a few notes on notation associated with probability distributions. If you've already looked at the binomial probability distribution, you will have seen this before. The variable x is distributed binomially with the parameters n and p, where n is the number of trials and p is the probability of success. With a normal distribution, the notation is very similar. The variable x is distributed normally. The parameters are quite different from those used in a binomial distribution. With a normal distribution, we require the mean and the variance, which is the square of the standard deviation. For example, here we have a variable which is distributed normally with a mean of 63. Our standard deviation is 5. And I find it helpful to mark on the standard deviations above and below the mean. And our question is asking, what's the probability that x is below 55? So I'll use that standardized score method. Our z-score is negative 1.6. If I go back to my table, the probability that a z-score is less than negative 1.6 is 0.0548. If you have a ClassPad calculator, using the Statistics app, we will calculate a distribution. We want to use the normal CD. In the previous example, we wanted a probability that a score was less than 55. So our lower bound is negative infinity and our upper bound is 55. Then we need to give the standard deviation and the mean of the distribution 63, 0.0548 to 4 decimal places. We can also now graph probability distribution, and the region that we're talking about is shaded. In example number 2, we've got 8,240 students given an IQ test. The mean score is 100 and the standard deviation is 16. X is distributed normally with a mean of 100, and remember we need to give the variance 16 squared. The question is asking how many achieved a score above 128. What's the probability of a student scoring above 128? Using the ClassPad, this time our lower bound is 128 and our upper bound positive infinity. The standard deviation is 16, the mean is 100. The probability here is 0.0401 to 4 decimal places. We need to multiply that probability by 8,240. Now if we highlight that value, we can copy using the up arrow, go into the main screen and paste using the down arrow and then multiply 330. In part B, we're asked to give the minimum and maximum scores of the middle 60% of students. Imagine a bell curve with a mean of 100. 68% of scores will lie within one standard deviation of the mean. But for the middle 60% of students, we need to use an inverse probability distribution. Back into statistics, calculate an inverse distribution. Normal CD again. We're looking for the middle 60%, so that's a centre tail. Probability 0.6, standard deviation is 16, and the mean is 100. Our two values are 86.5 and 113.5, both to 1 decimal place. And we can see what that looks like on a graph. We need to round so that we don't go outside of that 60% range. In other words, our minimum score would be 87 and our maximum score would have to be 113. In this final example, I'm not told the mean and the standard deviation, but I am told that the probability of a score being less than 55 is 0.7. The probability of a score being less than the mean is 0.5. Therefore, that score is above the mean. How many standard deviations from the mean is this score? So here's our table of normal distribution values, and we're looking for a probability of 0.7. 0.7 is between 0.6985 and 0.7019, but it's closer to 0.6985. So that means it's a z-score of 0.52. And that's the answer to question A, because our z-score is the number of standard deviations the score is away from the mean. Now, using a class pad, in the statistics app, we're going to calculate an inverse distribution, inverse normal CD, and this time the tail setting is left. Our probability is 0.7. The default is the standard normal distribution of standard deviation 1 and mean 0. And now we have a more accurate value for that probability of 0.5244 to 4 decimal places. Now for part B, we're given a value for the standard deviation and we're asked to find the mean. 55 is 0.5244 standard deviations above the mean. So we can write that as an equation. The mean plus 0.5244 standard deviations is equal to 55. And if we substitute a value of 4 for that standard deviation, we can now solve this equation. Which gives us a value for the mean of 52.9 to 1 decimal place. In the previous example, we were given that the probability of a score being less than 55 was 0.7. Another way of stating this is to say that 55 is the 0.7 quantile. This means that 70% of scores are below that value of 55, and so 55 can also be described as the 70th percentile or the 7th decile. You may have come across these quantiles before, the 0.25 quantile and the 0.75 quantile. They're known as the first or lower quartile and third or upper quartile. 25% of scores are below the lower quartile and 25% of scores are above the upper quartile. In this final example, we have a normal distribution with a mean of 20 and a standard deviation of 3, and we're asked to find various quantiles and percentiles. I've set up a dynamic normal distribution using autograph. You can see that as I move this x value, the continuous probability calculations are given. Here we have the quantiles and the percentiles associated with the various values for x. So the first question was asking for the 0.5 quantile, and it should come as no surprise that the 0.5 quantile is 20, because in a normal distribution we have the symmetry whereby the mean is equal to the median. The 0.5 quantile is the median. Now I can vary that graph to look at the 0.82 quantile, which is around 22.76, and I can also check those percentiles, the 24th and the 62nd, around 17.88 and around 20.9. What you should do to finish this lesson is calculate more accurate values for these quantiles and percentiles using your ClassPad calculator. Remember to use the inverse probability CD with a left tail setting.